Hello, this is Dr. Christy Patton-Lukes, a chemical engineering professor at Missouri S&T. In this lesson, we're going to be wrapping up our basic review of matrices and matrix operations by looking at determinants. Now, determinants are only for square matrices. They're defined, it's a very complicated sounding definition, but the determinant of A can be written either as the determinant of A or A with square bracket sides. And what that is, by definition, it is the sum of the term Aij times the cofactor of the ijth term. Now the cofactor is Aij, or the cofactor of Aij is -1 to the I plus j power times the determinant of this matrix M sub ij. Now M sub ij is what's left over of your original matrix if you scratch out the ith row and the jth column. The good news is, for small little cases, the type we usually work by hand, I don't really need to go through these fancy rules. But when we go to larger general definitions and get back into computers, we will need to come back to this. So let's look at a 2 by 2 matrix. And for a 2 by 2 matrix, what this says I'm going to do is I'm going to, for every term in here, okay, I am going to go across an entire row, and I'm going to take this times -1 to the I plus j power. So in this case, I plus j is 1 plus 1. So -1 squared, which is +1. And I'm going to multiply it by if I were to scratch out that row and column. So I'm going to take A11 times -1 squared and multiply it by A22. And then I'm going to come to this next position, and I'm going to take A12, multiply it by -1 to the I plus j, or 1 plus 2, so -1 to the third power, so that's going to be a -1, and then multiply that by what is left over if I scratch out that row and column. So I have those. Okay? Well, there's an easier way to do this, and that simply is, visually, I can think of it as the product of the diagonal, the primary diagonal, minus the product of the anti-diagonal. Okay? So A11 times A22 minus A21 times A12. Let's try this with this example. So the determinant of this is going to be 1 times 7 minus 0 times 3. And that's just 7. And so the determinant is going to be a number. It's not going to be a matrix, it's a value. We can also do a similar sort of shortcut trick for a 3 by 3 matrix. Now I could go through and play the game with the cofactors and the -1 to the I plus j power, but there's this handy shortcut where I can also just extend my matrix. So go ahead and recopy the first 2 lines. Now this is not mathematically rigorous. This is, oh, it gets me the right answer. But if I do that, and if I copy these first 2 columns, and I go through and I look at the diagonal, and do that for all of my things that go in that same direction, until I run out of starting spots, right? And then I'm going to subtract going the other direction. Following the same pattern. And that's just a faster way to get the answer that you would doing the cofactor method. So again, if you need to review the cofactor method, go ahead. You can kind of try it on your own. If it doesn't work out for you to get the same number, then go back and look at something like the Khan Academy videos. But in the meantime, this should be enough of a refresher to prepare you for next week. We're going to start looking at how we can use matrices in order to actually solve some really practical chemical engineering problems. And in fact, you've already seen these in your mass and energy balance class. So this concludes this little section of videos. Thank you very much for your time.